Alright, so we've been working on stoichiometry for a little while now, and one thing that we've been assuming this whole time is that our reaction works perfectly, and that all of our reactants make products. So, what we're actually going to find out happens in real life, this isn't always the case. Usually your reaction will not make all of the products you think it will. And there's a lot of reasons for this. You could have competing reactions, you could have some of your reactants decomposing, you could just have stuff stick to your container. But what's important about this is when it doesn't go perfectly, we need to know how much we actually made. And we're going to compare that to how much we should have made. So the first one we've got to worry about is our theoretical yield. This whole time, we've been doing theoretical yield because it's the amount of product that should be made according to your stoichiometry. That's important. Anytime a problem asks what your theoretical yield was, do stoichiometry.
Yeah, that's your math, guys.
Mm-hmm.
Math.
That's nothing new. We just haven't called it that yet.
You did math, and it said you should have so much.
Yes. So your actual yield is the amount you really did make in the lab, or the amount the problem says you really did make in the lab. It's a number. It will give it to you. It will say the actual yield was. Don't overthink that part. The closest you'll have to get to calculating that is using your percent, and we'll get to some examples of that. Okay. All right, so our formula is going to look pretty similar to back when we were doing percent composition. So percent yield just tells you how much you made compared to how much you should make. So our formula is going to be actual over theoretical times 100 equals our percent.
Equals your percent yield.
Mm-hmm. So see, really similar to what we've already done with percent composition, just slightly different values.
Because we know that anytime you have a percentage, you have to multiply by 100, so they all kind of look the same.
And it's got to be the part that you made over the whole that you should have made. That's where we get that. All right, let's try some problems. So this first one, you'll have to just follow along. So we've got our chemical reaction. We've got iron phosphate reacting with sodium sulfate, and we get iron sulfate and sodium phosphate.
Okay.
Yay.
So first thing we're going to do is identify our wanted and given. So I've got 25 grams of iron 3 phosphate. And that is my given. Right.
And then what we want to know is what?
I want to know what I want. So it wants to know what is my theoretical yield of iron sulfate.
And what did we just get done saying? What is theoretical yield telling us we need to do?
Theoretical says do the math.
Do the math. So do your stoichiometry. So we're going to set up our tracks.
Okay.
So when we're doing our stoichiometry, what do we always put first after we know what we were given and what we want?
We always put our given first. So we're going to set up our tracks. And I'm not going to put lines in until I get this in. 25 grams. And let's see, iron phosphate. Let's see, if we look at all the ones that have iron, this one is going to be iron phosphate. So FePO4
okay.
grams. Okay, line.
All right, so if we've got grams of iron phosphate on top, where else do we need grams of iron phosphate?
Okay, so it's going to have to be grams of iron phosphate on the bottom. And I want to change grams to moles.
Moles,
right?
so we're going to use our...
So we always change to moles to be able to do anything with it.
So we're going to have to use our, what do we call that?
Molar mass.
Molar mass.
Because 1 mole is always equal to the molar mass.
Right, so we're going to add up our iron, which should be 55.85, plus phosphorus, which is 30. Oh, right there.
This is up here.
30.97.
That's convenient.
Hey, I actually did remember iron, right? 30.97 plus how many oxygens?
4.
4 times 16. So our molar mass is going to be 150.82. Okay?
Okay. Lime.
So now we've gotten ourselves 2 moles of iron phosphate. How do we change from iron phosphate to iron sulfate? What are we going to use?
So anytime I'm going from one substance to another substance, I have to use my molar ratio.
Your mole ratio. So let's do our mole ratio, which comes from our
coefficients,
in
my balanced equation. So I need moles of iron sulfate on top, which is going to be this one. Fe2. Doesn't even look like a 2. Anyways, get the idea. So 4, 3. Okay. I'm going to run out of space because that's what I want. So it goes on top. And my moles of FePO4 go on the bottom because it's what I'm coming from.
Okay, and then what's our coefficient for iron sulfate?
Well, there's nothing there, so it must be a 1.
Just like X. All right, and so then iron phosphate is going to have a 2.
Okay.
All right, and so we're going to need one more set of tracks, which we're going to have to put below. It's always very important to make sure you've got enough space. All right, so then our last set of tracks, we're in moles of iron sulfate. What do we want?
We want grams of iron sulfate.
So what are we going to use?
Oh, the molar mass again.
Molar mass again. So we're going to do 55 point...
Oops. Just kidding.
55.85 plus 2 sulfurs plus... How many oxygens do we have in that?
12.
12. Oh, we actually have 3 sulfurs.
Yeah,
sorry. 3 sulfurs, 12 oxygens. Watch out for your subscripts.
Remember, anything outside of your parentheses gets distributed in and multiplied.
344.03 for our molar mass.
344. I'm just going to put 344.
There we go. All right, so we're going to multiply everything on top. So we have 25 times 344 divided by... We've got 2 numbers on the bottom.
Oh, no.
Make sure you use parentheses. If you don't use parentheses, you're going to multiply by 2 at the end. So 150.82 times 2. And so our theoretical yield, so what stoichiometry says we should make, is 28.51 grams.
Of
iron sulfate.
That is important, guys, because if you don't identify what you have at the end, we don't know.
All right, so now that's our theoretical yield. The next question tells us if the actual yield is 18.5 grams, what's the percent yield? What was our formula for percent yield?
Actual over theoretical times 100.
All right, so it gives us our actual. It's just whatever it says in the problem, over our theoretical, which was what we just found, which is 28.51 grams.
Times 100.
All right, and so if we do our 18.5 divided by 28.51, we get 64.9%.
So, not a very good turnout.
Well, it depends on your reaction. There are some reactions where getting 60% yield is pretty good. There are some reactions where getting 10% yield is good. It depends on what you're doing. This is one of the reasons why pharmaceutical companies charge so much for things, because they're doing a whole bunch of reactions in a row that all make a teeny tiny quantity out of what they're trying to do. And so if you're trying to do 5 reactions in a row, they'll give you 10% yield. You end up losing a lot.
So it costs them a lot of money.
It costs them a lot of money. All right.
Applications of chemistry to the real world.
All right, let's try. So this is actually the second part, because this is a slightly different way to do the math that throws people off sometimes. So here, it tells us our theoretical yield is 11.5 grams.
Okay, so I know my theoretical, and if my formula is actual over theoretical, then this one goes on the bottom.
Right. Then it asks how many grams of product will I get, so that's my theoretical that my actual that I'm looking for. So that we can just put in as X. And so all that's going to equal my percent yield, which is 65.
Okay, so this is just like any other algebra. We're going to reverse everything that's going on.
So we're currently multiplying by 100, so we need to
divide by 100. So divide by 100. So that gives me x over 11.5 equals
0.65.
And then I need to get x by itself. So if I'm dividing by 11.5, I need to multiply by 11.5. And what I do to one side, I do to the other.
So we do 65, sorry, 0.65 times 11.5.
X equals.
So our actual yield should be 7.48 grams.
It's going to leave a square here, but it's fine. He can put our box there.
All right. So that's all you have to do. If it gives you a percent, it gives you a theoretical. Plug it in the equation, do some algebra. It'll be okay. All right. Now is when you need to pause and try your guided practice on your own.
That's a really big number.
It was 7.48.
I was going to say.
Because you can't make more than you were supposed to make.
That's what I was like, that doesn't look right.
That's a problem. All right. So now we can pause and try the guided practice on our own. Come back and join us either when you're done or when you get stuck.
Yay.